Hi. In today's discussion, we will be looking at pure substances. We will be looking at pure substances. Pure substances. Maybe it may sound to be something obvious or easy to distinguish or to look at if a substance is pure or if it's not pure. You've heard of people talking of pure honey. You've heard of people talking of maybe pure milk and such stuff. But when people are talking of this, in science, purity is not regarded in that manner, but rather in science it is like very different. So we will discuss at how scientists can identify a substance as pure or impure. So a pure substance has a fixed composition. A pure substance has a fixed composition. A pure substance has a fixed composition. So pure substances are always homogeneous. Pure substances are always homogeneous. Are always homogeneous. They are always homogeneous. We saw what homogeneous means. They differ from mixtures in two main ways. They differ from mixtures in two main ways, and that is one, every sample of a given pure substance has exactly the same characteristic properties. One, every sample of a given pure substance, has exactly the same characteristic properties. Exactly the same characteristic properties. It has the same characteristic properties. So these properties are so specific that they can be used to identify the substance. So in contrast, the properties of a mixture depend on the relative amounts of the mixture's components. In contrast, the properties of a mixture, depend on the relative amount of the mixture's components. So in the first instance, a pure substance has exactly the same characteristics. I mean the same characteristic property, but the properties in a mixture depends on the relative amount of the mixture's component. So each component in the mixture will have its own property. Unlike in pure substance where the property is just one and exactly the same. 2, every sample of a pure substance has exactly the same composition. Every sample of a pure substance every sample of a pure substance has exactly the same composition. So if we took, for example, a sample of water, then all the sample of water will have H2O. All the sample of water will have H2O. So all samples of a pure substance have the same makeup. Like pure water has always 11, I miss here to write the right stuff, 11.2% hydrogen and 88.8% oxygen. So if you got a sample or a substance which is made of hydrogen and oxygen, and the ratio of hydrogen to oxygen is 11.2 to 88.8, then you will conclusively conclude that this is water. That is why we regard it as being pure. So pure substances are either compounds. Pure substances are either compounds or elements. Pure substances are either compounds or elements. Compounds or elements. So they can either be compounds or they may be elements. So a compound can be decomposed or broken down. A compound can be decomposed or broken down into two or more simpler compounds or elements by a chemical change. For example, water can be broken down into hydrogen and oxygen gas through electrolysis. E.g., water can be broken down. Water can be broken down into hydrogen and oxygen, through hydrolysis. So we will go back and check how this takes place, and we will go through a short video which will make it even more clearer. So as you can see here, it is very clear that when you are separating, as we have discussed, a compound, you have to decompose it. So decomposition of compounds. Decomposition of compounds. Here, separation by electrolysis. So passing an electric current through water causes the compound to break down into the elements hydrogen and oxygen, which differ in composition from water. So we are having here our water molecules, which is, of course, a compound. So this is a compound, and it is a pure compound. This is pure water. So this pure water can be separated into its constituents, and you can see here after hydrolysis where the gas moves here and it can be collected. So here we have oxygen molecules, and here we have hydrogen molecules. So you pour the water here, electric current is passed here, and the water will be decomposed into hydrogen and oxygen. Sometimes decomposition can be done by heating. When sucrose is heated, it caramelizes. When it is heated to a high enough temperature, it breaks down completely into carbon and water. It will break up completely into carbon and water. So unlike in mixtures, where we saw that the mixture can be separated easily by basically using the means that we discussed earlier, like by use of just separating it. In this case, things are not going that way, but rather the composition here has to be, the compound here, because it is pure, it has to be separated by chemical means, and that is by decomposition. Unlike in mixtures where we could even just separate by picking, removing one substance from the mixture. Laboratory chemicals and purity. Now we will look at laboratory chemicals and purity. So when we are talking about laboratory chemicals and purity, we are basically saying here that all chemicals that we know in fact have impurities. There is no chemical which is pure. All chemicals have some impurities. All chemicals have some impurities. The purity ranking of the grade can vary. The purity ranking of grades can vary with different agencies. So different agencies have their own way of measuring and because of the differences in measuring or how they find the composition of the compound, and they are different, their purities or finding the purity in them will differ. For some chemicals, the USP grade may specify higher purity than the CP grade, for example. For some chemicals, the USP grade may specify higher purity than the CP grade. So for other chemicals, the opposite may be true. However, the primary standard reagent grade is always purer. However, the primary standard reagent grade is always purer than the technical grade, technical grade for the same chemical. So chemists need to be aware of the kind of impurities in a reagent, because these impurities could affect the results of a reaction. So these impurities can affect the results of a reaction. That is why it is relevant for scientists to know the impurity of a chemical that they are using. So chemists need to get this information from the chemical manufacturers. So chemical manufacturers must ensure that the standards set for that reagent by the American Chemical Association are met. So reading and understanding the labels placed on chemicals, you can tell the purity of a substance. And it is a critical skill for a chemist to be able to identify how pure a substance is before he goes ahead and use it. So let's look at the example that we have. We will look at the examples that we have. For example, normally they will write, if you are having a bottle of a substance here, they will write what the name, or they will put the label. Then after putting the label, they can say, for example, ethanol. So you know that the chemical is ethanol, they can tell you 60%. 60% maybe water, maybe 35%, and then they can put the other impurities that may be there and so forth. So we will stop here for this unit 2, and we will continue with the next unit in the next coming discussions.